That means it corresponds to the gain. If the gain of a transistor is larger, that means it can operate as an amplifier. And to operate as a switch, it also depends on the gain, but the gain must be smaller. In that case, you will efficiently minimize the power usage of a transistor. Also, one of the important things about using a current in a circuit is to do with the current. We know that the switching phenomena of a transistor depend mostly on the current, and the operation of the transistor also depending on the current. So to understand a transistor's physical component, we have a part number which can identify different type of physical component of a transistor. And all these part number, if you look closely, they are related to the current handling capability of a transistor and also the power consumption. Different type of transistor have different current handling capabilities. Some they are used, for example, in an amplifier, they handle more current. Some they used as a switch, they minimize the use of the current flowing through the transistor. So all in all, we have the power consumption reduction by choosing a transistor, whether to use for an amplifier or used as a switch. And this is very important. That's why they have different sizes. They have different function based on these two. I believe by now you can know what is the type of transistor that we have, the symbol of a transistor, and some of the requirement of the physical component. And we have a transistor which is big in size and maybe small in size. And you can see they all have in common the 3 terminal. So you will have this pin correspond to a collector for the NPN, the middle one, the base, and the emitter at the end. So we'll move on to look at how a transistor can operate. The operation of a transistor. In this section, we will consider NPN transistor since it is widely used, and the operation is basically the switch, how they use NPN to operate as a switch in an electrical circuit. Given the symbol of the NPN, you have the collector, you have the base, and you have the emitter. How can a transistor be used as a switch? Let us now consider a switch. This is the symbol for switch. When the switch is closed, that means we have point A to point B. The current will flow from point A to point B. And when the switch is off, that means we won't have the current to flow from point A to point B. So that's the basic scenario. In most automation where you don't need to control the switching in an electrical circuit, that's where you can use a transistor. I will now draw a simple circuit which will help us understand how the transistor can be used as a switch. This is the base again, collector, and the emitter. Imagine you have a light emitting diode connected like this, and here you have positive 5 volts power supply, and this is the resistor base of a transistor. So this LED we want to control, so it must be on and off using the transistor. So how can this be possible? Imagine if we connect another power source in this region, for example a battery with a 5 volts potential. That means when we connect the battery, that means it will allow the current to flow through the transistor. And we know that between the base and the emitter is the region, PN region. So if we connect a positive 5 volts in this region, that means it will allow the current to pass through, because 5 volts is greater than equal to 0.7 volts for a silicon diode. And if this transistor is made up of the silicon material, that means by applying the battery at the base of the transistor in series, now allow the current to flow from this region, from collector to the emitter. So what do you think will be the state? So when the base is closed, we now have current flowing from the collector to the emitter. And what will happen to the LED when the switch is closed, or when we apply the 5 volts in this region? What do you think will happen to this LED? The LED will go off. And when we remove the battery from the base, that means we are removing the switch that will enable the LED to go on. So with the circuit diagram, we can draw up a table. This is for the switch, and we can say this is for the base, and this is with the LED state. So when the switch is closed, that means we have positive 5 volts applied to the base, and the LED will go off. And when the switch is open, we say we remove 5 volts from the base. In that case, the LED will go on. Now let me explain to you what really happens in the circuit. So when the switch is closed, that means all the current will flow from the collector to the emitter. No current will flow to the light emitting diode. And when we remove the 5 volts from the base, now we will have all the current flowing in this direction. And this current is now responsible for brightening up this LED. So why is that, you may ask? Because current choose less resistance path. And this is very important. You will have to understand and remember this every time. Let me explain to you this idea. Imagine you have positive 5 volts connected to a resistor and connected to a light bulb, and it is connected to the ground. Current will flow in this path to light up the lamp. If you now connect a wire between this portion of the line and this portion of the line, what will happen to the circuit? This circuit is now in a short circuit state. That means the current will now flow in this direction, leaving no current flowing in this direction. So if you see closely, you have the lamp which produce resistance, and you have the resistor which also produce resistance. But this region here does not have a resistance. That is why the current will always choose this path over this path. The same can be applied to our circuit. When the switch is closed, that means we apply 5 volts to the base of this transistor. The current will flow from this region, from collector to the emitter, and the LED will go off because no current will flow through the LED. So when we remove the voltage at the base of the transistor, that means no current will now flow from collector to emitter. The current will flow in this direction. That is why you can see that a transistor can be used as a switch in that scenario. In our later video, we will see some of the mathematical formulation of the current from the base and the emitter and current from the collector to the base. There are 3 modes of operation for a transistor. So in the later video, we are going to see that. But I believe in this video, by now you can understand how a transistor can be used as a switch in a circuit. I can also give you another example. In this example, I believe you can be able to figure out what really happens when we apply voltage at the base of a transistor and what will happen to the LED. And we compare with our diagram that we provide on the right. So imagine you have a circuit like this. This is again the battery and this again the 5 volts. The moment we connect the battery to the base of this transistor, this becomes a closed circuit and current is now flowing from the collector to the emitter. So what will happen to this LED? Now the LED will be on because it is a closed loop circuit. So current is flowing from the 5 volts all the way to the ground, which light up this LED. So we can draw the diagram, the switch and the base and the LED. So when the switch, we say the switch is closed, that means we apply 5 volts supply to the base, that means the LED will be on. So what will happen if we remove the battery from the base? That means the switch is open and we have 0 volts to the base of this transistor. Then what will happen? There is no closed loop path between the positive 5 volts and the ground. So this becomes an open circuit, so the LED will be off in that case. So can you see the difference between the operation that we discussed? The difference between the two is in regards to the circuit connection. So 2 sets of different connections were discussed. So I believe you will understand how a transistor operates. So thank you for watching our video. You can kindly like and subscribe for more future videos like this.